So, now what we want to talk about is solving polynomial equations, and today we're just going to focus on solving by graphing and solving by factoring. Over the next couple of days, we'll then discuss how we can solve any polynomial. But we have learned so far this year, we know that solutions, another word that we can use for that is also x-intercepts. So you can solve any polynomial equation by graphing. The limitation of this method is it will only give you real answers. Okay, x-intercepts are real numbers. The only answers that will show up are real answers. So if you have any imaginary answers, it's not going to work. So that is one limitation. It will only find the real answers, and it can only give you decimal approximations. It's not going to give you an exact answer. Now sometimes we get lucky, and they are nice, even numbers. That's fantastic, but most of the time it's not. They're decimal approximations. So these are some limitations of it, so that kind of limits when we can actually use this method to solve. Something that we do want to talk about, and we'll talk about more the actual rule and the theorem that goes along with it, is when you're solving a polynomial equation, you need to know how many answers you're looking for. If you remember, quadratics always had two answers, and all quadratics do. They were either two real, two imaginary, or the one repeated. You have to have two answers. Well, all polynomials have a rule to help us know how many solutions we should have, how many answers they have, and that is the degree. The degree of the polynomial tells us how many solutions there are. So if it is a cubed problem, then there should be 3 answers. If it's a fourth problem, fourth degree polynomial, then it should have 4 solutions. So the degree is going to tell us how many answers we're going to have. So that will help us when we're solving these problems. We want to make sure we get the right number of answers. So I'm going to solve this one by graphing. If I want to solve it by graphing, I have to graph it. So I'm going to go in my calculator into y equals, and I'm going to graph this equation. So y equals 3x to the third power minus 6x squared minus 9x, and then I'm going to graph it. And look at that. I have 1, 2, 3 x-intercepts, which is a good thing because this was x to the third power. I'm supposed to get 3 answers. Now, if you remember, the quickest way to find zeros is to actually go to the table and look for the zeros in the y column. So let's look in the y column here, and I do actually see 3 zeros. Folks, it is going to save you so much time to look at your table first. If you can find your zeros in your table first, I don't have to bother with the whole second trace thing, okay? Now, I can go to second trace, and I can choose 0, and I can try to find each one of these individually, but I would have to do each one individually, okay, by itself. Get the blinky thing on the left of it, get the blinky thing on the right of it, and then hit enter. -1 is one of my zeros. But if I had just gone to table, I could have seen that -1, 0, and 3 are all of the zeros and not actually have to type anything in. So don't forget that. You can use your table to do it. So it looks like we have 3 zeros. We have 1, -1, 0, 0, 0, and 3 zeros. So our zeros are actually going to be, that means our solutions are going to be x equals -1, x equals 0, and x equals 3. So we got 3 solutions for our problem. 3 solutions. So we now know what x is equal to. X is equal to -1, x is equal to 0, and x is equal to 3. So I solved by graphing. So that is one option. Now, again, can only get decimal approximations for that, so I do need to have an option for getting all the exact answers, and factoring is our option for getting exact answers. So solving by factoring is going to be our option if we can't solve by graphing. If we graph it and we don't find all the answers, or they're decimal approximations, or maybe there's not any real answers, it's all imaginary answers. The only way you're going to get imaginary answers is to solve by factoring. So we have to have options for factoring. So that's what we reviewed, factoring. Now, to solve by factoring, you do need to know your first step is going to be to get your equation equal to 0. If it's not equal to 0, we can't solve by factoring. So you always want your equation to be equal to 0. If it's not, add something to both sides, subtract something from both sides, move it over. So you have to make sure that your equation is equal to 0 first. Your second step is then going to be to factor whatever polynomial you have on that side. After you factor it, that you're then going to set each factor equal to 0 and solve for x. So you're basically trying to break this down into smaller little problems that turn out into nice, neat little equations. So let's go back and remember, this is a perfect cube. Is 64 a perfect cube? If you don't remember, go and make a list of perfect cubes. So if I do x cubed and go to table, here's my list of all my perfect cubes. So it looks like, is 64 on that list? Oh, yes it is. 64 is a perfect cube. In fact, it is 4 cubed. So that works out nicely. So this is a sum of cubes, and we did learn how to factor that. It's always going to be a binomial and a trinomial. So I take the cube roots. The cube root of x cubed is x. The cube root of 64 we saw on that list was 4. So we took our cube roots. Now I need to square both of these. So I'm going to get x squared and 16. I need to multiply the 2. That's going to give me 4x. And then I've got to put on my soap. Same, opposite, always positive. So same, opposite, always positive. So this is now factored. Now my rule says that I need to take my two factors and set them equal to 0 and solve. So I'm going to get x plus 4 is equal to 0. And I'm going to get x squared minus 4x plus 16 is equal to 0. Folks, this is linear. Hopefully you can manage this one. If I subtract 4 from both sides, I'm going to get that x is equal to negative 4. So there's one of my 3 answers. Here's the problem. This is a quadratic. Quadratics have 2 answers, which is a good thing because we're supposed to end up with 3 answers. But whenever you factor a sum and difference of cubes, the quadratic you're left with is guaranteed to be a not pretty one. It is not going to turn out to be something that is factorable. So you are going to have to solve it by either completing the square or the quadratic formula. It's usually going to turn out to be imaginary or at least irrational. So quadratic formula or completing the square is going to be your best option. So let us review for a moment the quadratic formula. You can't forget the quadratic formula. So when we're doing the quadratic formula, it's the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So in this particular problem, a is equal to 1, b is equal to negative 4, and c is equal to 16. Don't forget when you're doing the quadratic formula, you want to do what's inside here first. So I'm going to take my calculator, and I need to do negative 4, which notice I put it in parentheses. Don't forget to put it in parentheses. B squared minus 4 times A times C. There we go. B squared minus 4AC is negative 48. So I've got the square root of negative 48 plus or minus. Now the opposite of B would be positive 4. And 2 times 1 would be 2. So is there a perfect square that will divide negative 48? Let's try 4. 4 works, but I think something else will. Let's try 16. If 4 works, we should always check 16. Yeah. So it looks like this is going to be negative 16 times 3. And don't forget, square roots of a negative, imaginary. That's why this one wasn't turning out to be pretty. So x is going to turn out to be, let's see, the square root of negative 16 is 4i on the square root of 3. We've got 4 plus or minus 4i all over 2. This will reduce. It looks like both of these divide by 2, so I can distribute. I'm going to end up with 2 plus or minus 2i on the square root of 3. So this is 2 answers. Don't forget that. It is 2 plus 2i on the square root of 3 and 2 minus 2i on the square root of 3. But that gives me 1, 2, 3 answers. So that is all 3 answers for this particular problem. So don't forget, factor, get it equal to 0, factor, set the factors equal to 0, and solve. Now we did have one other factoring case. Let's look at the quadratic type. When you've got the quadratic type, it's a trinomial. This is a perfect square. This is half of that power, so this is a quadratic type. So I need 2 numbers that multiply to equal negative 18, but add to equal 7. So I'm thinking 9 and negative 2. That would multiply and then add to equal 7. So that means this must factor to be x squared plus 9 and x squared minus 2. Now that it's factored, I can set my two factors equal to 0. X squared minus 2. Now we're lucky in these. We can use the quadratic formula, but we don't really have to. This is one of those special cases where we said we had the x squared but no x, so we could solve by square roots. So if I subtract 9 from both sides, I'm going to get x squared is equal to negative 9. And when I take the square root, now when you take a square root, how many solutions do you have to get? You have to get 2 solutions. So I'm going to remember my plus or minus, and the square root of negative 9 is 3i. So there's 2 answers. Now, if we go back up to the original problem and look, this was x to the 4th. I'm supposed to end up with 4 answers, so I do need to get 4 answers. There's 2 of them. Now, if I add 2 to both sides, I'm going to get x squared is equal to positive 2. So at least when I take the square root of this one, I'm not going to get an imaginary number. I am, however, going to get 2 answers, because I've got to do plus or minus, and the square root of 2 just doesn't reduce anymore. So that's going to stay the square root of 2. So now I have 4 answers: positive 3i, negative 3i, positive square root of 2, and negative square root of 2. X to the 4th power means 4 answers. I got 4 answers.